Have you ever stopped to think about how your computer actually remembers anything? I mean, from your saved games to that report you just finished, it's all handled by this incredible hidden system of memory. So let's pull back the curtain and see how it works. So here's the central mystery, right? You're in the middle of a game, the power flickers, and poof, it's all gone. But your photos, your documents, they're totally fine. Why? Well, that's the whole difference between a computer's short-term and its long-term memory. And figuring that out is the key to, well, everything.
All right, first up, let's talk about the memory that handles what's happening right this second. It's a special kind called RAM, and it is built for one thing and one thing only: pure, blistering speed.
So what is RAM? Well, it stands for Random Access Memory, and you can just think of it as your computer's temporary desk or workspace. Any app you open, any website you're on, it's all living in RAM. But here's the big catch. RAM is what we call volatile. That just means when the power goes away, so does everything on it. Instantly, no warning, gone.
Okay, the best analogy for this is to think of a whiteboard versus a notebook. RAM is that whiteboard. It's super fast to scribble on, make changes, erase things. It's flexible. Your hard drive, on the other hand, that's your notebook. It's a bit slower to write in, sure, but once it's in there, it's permanent. Now, if someone unplugs the power, it's like they've wiped the whiteboard clean. All your amazing work just vanishes.
And that leads to a really important question. If all the real work happens on this speedy but forgetful whiteboard, how do things like your bank's database or an online store make sure they never lose your data if the power goes out? I mean, they can't, right?
Well, they use this brilliantly simple trick called a write-ahead log. Here's how it works. While the database is flying along making changes on that super fast RAM whiteboard, it's also jotting down every single one of those changes into its permanent notebook, the hard drive. So if the power suddenly goes out, yeah, the whiteboard gets wiped clean, but who cares? The notebook has a perfect step-by-step record of everything that happened. You just replay the log, and it's like nothing was ever lost. It's the best of both worlds. You get the speed and the safety. So let's dive a little deeper into that permanent notebook. This is the world of storage. It's the computer's library, where all your files and programs get to live safely, even when the power is completely off.
For a really long time, the king of storage was the hard disk drive, or HDD. The easiest way to picture one is like a miniature record player. Seriously, it has these spinning metal disks called platters and a little arm that zips back and forth to read or write your data. All those moving parts mean it makes a little noise and isn't the fastest, but boy, is it reliable.
Now, the new kid on the block is the solid-state drive, or SSD. And the name says it all. It's solid. There are zero moving parts. It's all electronic. You can basically think of it as a giant, super fast version of a USB thumb drive. And because there's no moving arm, it's way faster. And totally silent. So if you put them side by side, the difference is pretty clear. Speed is the big one. SSDs just blow HDDs out of the water. But there's always a trade-off, isn't there? A hard drive, with its spinning disks, can basically be rewritten a near infinite number of times. The little electronic cells inside an SSD, though, they can actually wear out after being written to many times. And this brings us to one of the weirdest things about SSDs. Even though they're faster overall, the way they handle small changes is, well, it's kind of bizarre and complicated. Okay, imagine your notebook had this crazy rule. You can't just erase one word. To change a single word, you first have to find a totally new blank page. Then you have to copy the entire original page onto the new one, but with your one little change. That's what an SSD does. It copies a whole chunk of data called a block to a new location, makes the change there, and then marks the old block as trash. It sounds wildly inefficient, I know, but it all happens in a flash, so you never notice. So we've got our super fast RAM whiteboard for active work and our permanent notebook for safe storage. But what happens when your whiteboard just isn't big enough for all the stuff you want to do? That's a problem computers hit all the time, and they solve it with what is basically a magic trick. Just think about it. You've got your browser open with like 50 tabs. You've got your music playing, maybe a game running in the background. Every single one of those programs is screaming, "I need memory. Give me some RAM." How on earth does the computer keep it all from crashing down? It uses this amazing illusion called virtual memory. Here's the idea. The operating system tells every single program, hey, don't worry, you have your very own massive private memory space all to yourself. Think of it like this. Every apartment building on a street can have an apartment 101. There's no conflict because they're in different buildings. The computer does the same thing.
It gives every program its own virtual building and then secretly maps those addresses to the real, physical RAM. And here's the real magic. Let's say you haven't clicked on one of those browser tabs in a while. The operating system sees that and quietly, sneakily, moves that tab's data from the expensive, fast RAM over to the slower hard drive. That frees up RAM for whatever you're doing right now. The second you click on that old tab, whoosh, the OS brings the data right back. It happens so seamlessly, the program never even knows it was gone. It's an incredible trick.
All right, so we've got all these different layers of memory and storage working together, but how different are they when it comes to speed? The answer is absolutely mind-boggling. At the very, very top of the pyramid is something we haven't even talked much about, called CPU cache. It's a tiny bit of memory built right onto the main computer chip. Accessing it is basically instant. Then there's a huge drop down to RAM, which is still incredibly fast, don't get me wrong. But then there's another massive plunge in speed to get to an SSD. A hard drive? Oh, it would be a tiny little sliver way down at the bottom of the screen. We're not talking about small differences here. Each step down is orders of magnitude slower.
You know, this is probably my favorite analogy to really feel the difference. Getting data from that CPU cache, that's like grabbing something that's already in your hand. RAM is like reaching across your desk for it. An SSD is like having to get up and walk into another room to find it. And a hard drive, that's like having to find your car keys, get in the car, and drive all the way to the store. The difference in effort and time is just enormous.
So how does your computer manage all this insane complexity? The good news is, it doesn't have to. These days, storage drives have their own little computer brains built right in, called controllers. These chips act like dedicated managers. They handle all the messy details, like where to physically put the data or how to clean up all that trash on an SSD. This lets the main brain of your computer, the CPU, focus on the important stuff, like running your programs.
So if you take one thing away, it should be this. It's all about trade-offs. You use RAM for incredible speed, but you accept that it's temporary. You use SSDs and hard drives for permanence, but you accept that they're slower. Virtual memory is that beautiful magic trick that bridges the gap, making a small amount of fast RAM feel nearly infinite. And all the while, these smart little controllers are managing the chaos behind the scenes to make it feel effortless.
This constant dance, this balancing act between speed, permanence, and cost is what has pushed computer science forward for decades. Engineers keep inventing these clever, brilliant tricks, from write-ahead logs to virtual memory, to try and give us the best of all possible worlds. It really makes you wonder, what's the next big trick going to be? What's the next clever idea that's going to change the game all over again? Thanks for watching.